Okay, and welcome to Unit 10. And before I get too far into it, I want to show you what I was doing yesterday. Here's a picture of me with my Stand Up for Science shirt, which I should be wearing Monday, maybe even Monday and Tuesday in class. And I wore it yesterday in DC, the start of the march. It's right back there. We got there about a quarter of 2. March starts at 2. Ended up walking about 4 blocks that direction, works out about 3/4 of a mile, and stood there for 50 minutes. We could tell that the march started, but it took 50 minutes for the people that were in between me and the start and the back to get moving. It was a really popular place. And this is myself and my wife, Leslie. And here's a picture of us from high school back in 1976. Okay, so let's get started with Unit 10, Galaxies. This is one of my favorites. I love looking at pictures of galaxies. I really wish we would have some of these things in our sky. We do have Andromeda, which I'll show you a picture of, that works out to be about 3 times the size of the new moon, but it's 2.4 million light years away. It's our closest neighboring big galaxy. And because it's so far away, we don't get to see much. In fact, the only thing we really get to see is this very center section of Andromeda. This is not Andromeda. This is my favorite galaxy. This is called the NGC 1300. There are a whole bunch of people in the NGC, which is a catalog of galaxies and nebula and other things, and we'll talk about that, I think, on the next screen. But this is a beautiful barred spiral. Beautiful arms coming off of a bar, which is that central section. This is a spiral galaxy where the arms actually come off the center section, but if it's a bar like this, works out really well. In this picture, you can start seeing some of the other galaxies that are around. They have elliptical. These are probably spiral, if not barred spiral. And that almost looks like there are bars out there. If I could zoom in a little better, but you can actually, this is Messier, or M83, and this is NGC. 2 ways of actually categorizing things. This is 83 and this is 1300. Okay, we have Charles Messier that actually started looking at things up in the sky. Andromeda Galaxy is right here. And what was that number? 83. 83 is sitting right there. And you can see we don't really get different views of it because we're looking from here on Earth. We don't get to zip over to the other side of it or zip, 49 million light years away to actually get a different view. So we pretty much are stuck with the view of the galaxy that is given to us. There's some really beautiful galaxies in here, but what Messier did is he actually found 110 objects in the night sky that he wanted to categorize because he didn't want to get them confused with the things that he really wanted. So basically these were the 110 things he never wanted to see again. Because his telescope was so long ago and because Messier was there so long ago, we had some real issues with some really beautiful things that he saw. Lots of clusters, but some really beautiful galaxies also. And the NGC stands for the New General Catalog of Nebula Clusters of Stars and contains 7,840 objects. So I didn't put a picture of those up here, probably because there isn't one. But when you see NGC, that's what this is. And when you see M, that's what this is. Messier catalog, or the general catalog. So what do you think? Do all galaxies have spiral arms? Are galaxies isolated objects? Are all other galaxies moving away from the Milky Way? If you remember, that's a redshift. And this is an artistic view of the Milky Way galaxy. I don't know if you can actually see, but it's a barred sort of thing. And I think we'll actually see one of those in a couple more slides. So what are we going to discover in Unit 10? Whoops, I thought these came in one at a time. How galaxies are categorized by their shapes. So they're not all spirals. Are galaxies, that galaxies contain huge amounts of dark matter, nebula, for making new stars. That galaxies are found in clusters. They're actually grouped together. And some galaxies merge while others devour their neighbors. So they merge to actually make bigger things and they devour to make bigger galaxies. And that the universe is expanding. This is Hubble's called tuning fork. If you know what a tuning fork is, you hit it and it gives you off different letters like middle C or E or whatever, but it actually has got the categorizing galaxies, and he used it as a life cycle, saying that they started this way and they either broke off this direction or this direction and may ended up over here, but we now know that this is not a life cycle, it's just a way of actually categorizing the shapes of the catalogs of the galaxies. Sorry. I just got rudely interrupted by that wonderful wife of mine. Okay, and this is a depiction of the Milky Way galaxy. It's actually showing you a bar with the arms going off, and it's got a picture here of a bear. So what I would like you to do is I'd like you to draw this, a very rough diagram. Please draw that central arm. It's the galactic bar, and it actually says we have a long bar as well as this galactic bar. And then I'd just like you to draw the Sagittarius arm coming off it, going this direction. The Centaurus arm going off in this direction, and all that means is here's the sun. When we look in this direction we see Centauri. When we look in this direction we see Perseus. When we look in this direction we actually get to see Sagittarius, and we'll talk about that when we actually look at a real depiction, a real picture of our Milky Way galaxy. But this is giving you the idea that the sun is not in the center. We're about 30,000 light years away. I'd like you to add that to it. We think we're on what's called the Orion spur. Spur is just a smaller arm, not one of the really big spiral arms that come off, but just a spur. We think it's about 100,000 light years across from one side to the other. So if you actually looked into the middle of the Milky Way, you're seeing stars that are 30,000 light years away. If you could actually see all the way through the middle, all the way to the far side, and you can't because there's so much stuff, a lot of nebula, dark matter, lots of stars, big black, super black holes, lots of things in the way. But if you could see all the way across, you'd see 70,000 light years away. And then if you could actually look from one side to another, it's 100,000 light years. So I'd like you to draw the two big arms. Not sure where this Perseus arm differentiates itself from the Sagittarius arm, but you can see we have one arm coming off this bar, we have one arm coming off this bar, and then we have spurs. And what I would really like you to get is the Sagittarius arm, the Centaurus arm. Maybe you want to write this as the Perseus arm, but we think we're on what's called the Orion spur, sitting right there. Don't have to put any of these circles, don't have to put any of these things. I would like you to make a line that says this is 100,000 light years. I'd like you to make a line that says this is 30,000 light years, but that's about it. And you can stop the video at this point and actually see that. Okay, so here is a belly button. I think it actually got a tattooed face on it, but what I want you to imagine is if you were us, like a belly button, looking at what we see around our sky, would you be able to identify our galactic type? Would this belly button be able to look and see what kind of a critter it's actually attached to? And the answer is probably not. It could maybe look at a dog and see it's not a dog, and can maybe look at a tree and it's not a tree, but it wouldn't be able to look at a human and say definitely that it actually is from a human. Here is a Milky Way galaxy, and that's actually one of the websites I want to show, and I'll show that to you as soon as I show you the next couple of pictures. This is the same Milky Way galaxy picture, although somebody took it and tilted it, which I think is probably a little bit more normal looking. If you actually look at the constellation Sagittarius, which is a summer constellation for us, we'll actually get to see it really well in our summer sky. But if you look at the Sagittarius constellation, it almost looks like the Milky Way comes out of this spout. But the center of the Milky Way galaxy is located right here. And I'll show you that one also. And then I won't show you this one because it's a YouTube link, but I'll show that to you in class. Okay, so let me escape that one. Let me go to this picture. This is the first one I showed you that's linked. And if you take a look, can you find the center of the Milky Way galaxy? This is a 360 view of the Milky Way galaxy. You can see there's another galaxy right there, which is probably Andromeda. Can you see where the constellation, you can see lots of dark matter that block things from the background. Lots of dark matter right in here. And hopefully you can actually make out that this is the center of the Milky Way galaxy. This is why when we look around, we can actually see a low concentration opposite. So we're looking through a smaller part of our galaxy, and then as we get closer, we see more and more material and a bigger blob. This is called the halo of the galaxy. We get to see a lot more of this central bulge. And the other one looks like this, and there's music to it. I'm not sure where this picture is taken, but there's the Milky Way. That's the center part of the Milky Way galaxy. And as we spin around, we move to the other horizon, and this is what the galaxy would look like if you saw it in the summer sky. This is probably the summer, but it's probably way up high. And you don't get to see the whole Milky Way because 50% of it's below the horizon. Okay, so can I go back into, close it? Looks like I closed it. Okay, so types of galaxies. I would like you to draw this picture. You saw it before, and this is the Hubble's tuning fork. And it's got a line that goes into it with the tuning fork, and you can do that. And I'd like you to draw a pretty circular little section of stars, and they get a little bit more elliptical as we go from the EOs to the E7s. And then we have what's called the SO. I'll show you an image of an SO galaxy, and then they break from here either into S galaxies or SB galaxies, and with the A, the B, all the way to the C, and even D and E, and even later on in this one, but a really simple one. And what we actually have on this is we have what are called S galaxies. These are the spiral galaxies, and they go this direction. And as you go from A, tightly wound arms, to B, loose, a little more loose, and then C, really loose arms, meaning there's a lot of space in between the arms. And if we go farther this direction, they get less spiral-like and more open-like. Then we have what are called the bar spiraled arm of this tuning fork, and they have A's, B's, and C's, and again it has to do with the bar and the spiral arms coming off if they're tight, or they get more open as we go towards C's. Then we have what are called elliptical galaxies. These go into it, and like I said, we used to think this was a life cycle. They started off as elliptical, and they either broke off going spiral or barred spiral, and then eventually they went up and became these irregular galaxies, the IRRs. 35% of all the galaxies we see are spiral, 35% are barred spirals, so 75% are really the spiral galaxies. Then we have elliptical galaxies, which makes 25%, and we have irregular galaxies making up 5% of the galaxies. And hopefully my math is correct, and that's 100%. Here's some real pictures of the galaxies. You can see an E2, pretty round. That would be located right about here. We have the SO minus, which would be located a little bit before SO. And then we have SOO, which would be there, and we have SO plus, which is starting to break off. I'm not sure exactly where. And then we have tightly wound spiral arms, and then we get a little more loose as we go this direction. You can see there's a D, there's even an M, which gets sort of amorphous but armed. And then we have SAs, still we have that, and then we actually get into SBs in here somewhere, way down here, tightly wound, and they get looser, more loose as they go in this direction. These are pictures of the Milky Way, or the galactic types. Here's another tuning fork with some real galaxies, and you can see they start off with round and they get more cigar shaped as we go to an E7. And then the SO galaxies, which are more circular, sort of like this, but they're starting to show some evidence of arms, and they either break off to the S or the SBs. And you can see tightly wound, and they get a little bit more loosely wound if they've got bars, or they actually have tightly, more loosely bound spirals. And this is what we pretty much think we are. We used to think we were SC, and we probably think we're an SBC because we think we really do have a bar. Here's even a more complex Hubble tuning fork. This is from the Spitzer Infrared Nearby Galaxy Survey, called the SINGS. And it actually starts off with elliptical galaxies. They go off into spirals, and then we have unbarred spirals, so they get so open that we can't really see the arms, but we can see that they had arms. And then we actually have the barred spiral that go this way. They get more and more open as we go this way. And then we have what are called intermediate spirals. These are ones that are somewhere in here, somewhere. and then we have irregular galaxies. And we're going to do all of this after we do the activity Monday and Tuesday in class. I'll post this video Monday when I get home. Okay, so spiral galaxies, the first type. Again, we have SAs, SBs, and SCs, and they get more, they're all spiraled, but they get more and more open spiral, and it's a subjective kind of a thing. You have to look at it, and it's a little bit of objective, but it's mostly subjective. It's how open do you think the arms are, and it's a lot easier to actually see them when the galaxy is face on. Almost like Andromeda is. This is M31. This is our closest neighboring galaxy, and we only get to see this very central part because the rest of the stuff, 2.4 million light years, is so far away. And most of the big things you see here are actually stars of the Milky Way galaxy that we see. Even some of these small ones are Milky Way galaxies. If you can see them as individual stars, unless they're exploding stars on Andromeda, which I don't think they are, these are all stars of the Milky Way galaxy, which are just sort of in the way. This is probably one of the Magellanic Clouds, or it's another galaxy farther than the Andromeda galaxy, and I'm not sure which one that is right now. Okay, and these are spiral galaxies seed edge on, and I'm not sure how you can actually see this as an SA galaxy because it pretty much is off. This is called the Sombrero galaxy. Sort of looks like a hat with a wide brim. And then we have this is NGC 891. Pretty much again, we think that's an SB, so the arms are a little more open. And then we have the NGC 4631, which they're saying is SC. The galaxies I'm going to show you in the activity will not be these edge on, they're going to be face on. Then we have varieties in the spiral galaxies. This is actually M33, and it's a spiral galaxy with flocculent spiral arms. And all that means is we have things that look sort of like cotton or feathers. And these are explosions inside the galaxy where we've had nebula explode. And they sort of show you the arms of the galaxies. And then we have this one, which they're saying is more like ripples in water. But you can sort of see the spiral shape of these galaxies. Then we have the barred spiral galaxies, which actually do have bars. SBA, SBB, and they get more open with an SBC. Then we have elliptical galaxies. The EOs are more circular, and then as we move farther in the E's, we get more elliptical to an E7, which almost looks like a cigar-shaped galaxy, but you'll see examples of those in the activities. Irregular galaxy, or I guess you said you have seen them in the activities, and irregular don't really have any shape. This is the large Magellanic Cloud, which is visible in the southern hemisphere, and Magellan actually discovered it. It's a small neighboring galaxy of the Milky Way. And this is NGC 4485, which is supposedly an irregular too, and it's also NGC 4490, which is actually an open-armed galaxy. So we probably have the irregular ones down here, and we have the open arm one down there, but they seem to be either very closely associated in real life or really closely associated in terms of the picture that's taken here. And this is the last picture, and I want to show you that sometimes astronomers don't really want to see true pictures. They want to see the negative of the galaxy because it shows more definition. And we're going to actually be looking, I'm going to actually take a look, and I may be doing a different activity if I can find the one that I used to do on negative galaxies. But anyway, that's the end of 11A. Okay, thanks for stopping by. Adios.